f over g all over g. In the numerator, get a common denominator. So what would I have to do to get a common denominator in the numerator there? I'd have to get a g on the bottom here and a g on the top there, right? So now I'm going to be at the next line, which is, what, g times f prime? Can I say instead f prime times g? Isn't that the same thing? Minus g prime times f all over the common denominator all over g. And then I can look at the g on the bottom as a g over 1, right? And flip it. Flip it. And when I flip it, it becomes a 1 over g over here. That's gone. And then just multiply straight across. And you get f prime g minus g prime f all over g squared. And that is the quotient rule. In some ways, it's similar to the product rule, isn't it? I mean, product rule was what? If you have f times g, the derivative is what? F prime g plus g prime f. The quotient rule is f prime g minus g prime f, so it's a minus instead of a plus, and then one huge additional thing, what? Divide by g squared. Okay? Now, I'm a huge fan of this formula. So the two that we have today are, if you have f times g, that's equal to f prime g plus g prime f. That's your product rule, right? If you have f divided by g, then it's f prime g minus g prime f over g squared. The book, which I'm not a real big fan of the book, their formulas are a little different. So I'm going to do the book over here in red. The book does this. They say the derivative of f times g is f g prime plus g f prime. And they say the derivative of a quotient is g f prime minus f g prime all over g squared. So why do you think I have a problem with the book's version? Why do you think I like my version better? I mean, are they the same formulas? Look at this one. This one's f prime g. Well, there's f prime g, right? Plus g prime f. So they've got a different order, but its addition doesn't matter, right? Then over here, they have a g f prime. I have a g f prime minus f g prime. I've got that all over g squared. So why is it that I don't like the book? Yeah, they don't look like each other, right? Like the formula on the left for the book, you have to remember fg prime plus gf prime. This one's completely different, right? gf prime minus fg prime. The way that I put it out here, all you have to remember is one thing. The quotient rule gives you a subtraction, and you divide by g squared. If you can remember this, then you should be able to get quotient by just adding a few little things to it. Does that make sense? So if you try and follow the book in the way they do examples, just be aware that they are going to use the red formulas as opposed to the ones in black. Anyone who's maybe taken Cal 1 before, or seen it before, if you call this the high function and you call this the low function, like in a numerator is the high one, the denominator is the low one, then the quotient rule becomes, let's do it with the red though. It's the low function, right? Isn't g the low function? Low times the derivative of the high, right? Minus the high function times the derivative of the low function all over the low squared, right? I know that seems weird, but it's like a thing that you can kind of say. Low D high minus high D low. Low D high minus high D low over low squared. I've heard it before. I've never taught it. It's not something that I'm a big fan of, but some people love that thing. So, all right, you ready to do some examples now? Find y prime. And I'm not saying simplify, just find y prime. So do you have a quotient here? Do you have division? Yes. So you have your division here. You have like an f on top and a g on the bottom, don't you? So the derivative is going to be, let's try and remember it, f prime g minus g prime f all over g squared. Do you know what f prime is? Do you know what g prime is? Yes? If you know those, they're pretty clean. You should be able to just plug everything in right now. F prime is 6x plus 5 times g, 1 minus x, minus, what's g prime? Negative 1 times f all over 1 minus x squared. You know what? Let's simplify. And simplify. I'm adding to the rules, to the instructions. That would be considered to be the raw derivative right here. That's the raw derivative. But let's do some algebra to clean it up. So I'm going to have to FOIL out the top left. 6x minus 6x squared plus 5 minus 5x plus 3x squared plus 5x all over 1 minus x squared. So I actually had to FOIL out 6x plus 5 times 1 minus x. I did that foiling. Here it is, first 4 terms. And then on the second one, the two negatives became a plus. And so I just added these two right here at the end. And now I can collect like terms and I should be done. Put it in descending order. Negative 3x squared. How many x's do I have? Six x? Any constants? Plus 5? Is this right? Y'all have any? Did I make a mistake or anything? Does anyone see any mistakes? The bottom, you can leave it as is because it's already, you could argue that's already simplified because it's like factored. But if you wanted to, you can multiply it out. Now, do you remember that question that was asked a little while ago where we took a vote to see if we were going to do it? It was this one. G of t equals 1 minus 2t. Was this the one we did? No. Yeah, well, we'll get back to it. This wasn't the one we voted on, but this is the one we did. Right? Someone did ask about this? Right? You asked about that one, right? This was number 25 from 2.2. And we had to find the derivative of that using the definition, right? And we came up with an answer, which we'll look back at in a second. But now, let's do it using the quotient rule. Because don't we have a quotient here? We have f over g. So the derivative, watch the way I'm going to write this, capital G prime of t, the derivative of this should be f prime g minus g prime f all over g squared. I've memorized that. You should do the same. Do you know the derivative of f and g independently? Do you know those? Yes? All right. What's f prime? Negative 2 times 3 plus t, that's g, minus derivative of g, 1 times 1 minus 2t all over 3 plus t squared. Clean it up. Negative 6 minus 2t minus 1 plus 2t. So distribute your negative 2 through the parentheses, distribute your negative 1 through the parentheses, and at the end you should get, what? Negative 7 over 3 plus t squared. And does that match what we got earlier? Yes. Very nice. Another example. Let's let y be equal to secant x. Find y prime. Now, everyone should be able to tell me this answer because it's in your formulas, right? What's the answer to this? Secant x times tangent x, right? That should be the answer. But no, you're not allowed to use no formulas here. No formula allowed. So if you don't have a formula, what is secant x? By definition, it's 1 over cosine x, right? And isn't that a quotient? F over g. Yes? So the derivative here should be f prime g minus g prime f all over g squared. Now, you're allowed to use a formula for cosine, only because it was a bonus question. I showed you the derivative of sine using the limit, so let's act like we're okay to take derivative of cosine. So what's f prime? Careful here. What's f prime? 0, because f is a constant, isn't it? So you get 0 times g, which is cosine x, that's not going to matter, minus, what's the derivative of cosine x? Negative sine x, right? Times 1. Don't forget these things, right? We have f is 1, g prime is this, g is that, f prime is that, right? They all come from something here. All over cosine squared x. You can do it two ways. You can do it this way, or you can put the cosine in parentheses and square it. All right. That equals what? The 0 times cosine x is gone, right? Minus a minus is plus, so we have sine x over cosine squared x